Hi, and welcome back to another video. And in this video, we're going to go over the composition and the combinations of functions. This is for chapter 2.6. Let's just jump right in. So what do we have here? It says, select the answer that best completes the given statement. We exclude from a function's domain real numbers that cause division by 0. Yeah, you cannot have 0 inside the denominator, and we're going to see those a lot. That would be the dead giveaway. Whatever will make the bottom equal to 0, we're not going to put it in there. It should be excluded. So for example, what would make the denominator here equal to 0? Well, the best way to figure that out would be to set the bottom equal to 0 and solve for x, the denominator. So we're going to put x plus 6 and put equals 0 and solve for x. And you know what? Just to make things a little bit more clear, we're going to put a cannot equal to symbol. So whatever x cannot be equal to, that's what x cannot be equal to. All right, anyway, let's solve for x. So minus 6, you get x is equal to negative 6. We're using the slash, so x cannot be equal to negative 6. So if you were to make a little number line, you know, we have 0 somewhere here. Then we have 1, 2, 3, 4, 5, 6. This is negative 6 over here, right? X cannot be equal to that number. So you can imagine if everything is shaded except for this portion here. So if that's okay. Everything to the left, like negative 7, negative 8, negative 9, all of those are okay. And everything to the right of it is okay, right? You know, negative 5, negative 4, negative 3, negative 2, negative 1, 9, 10, 11, everything except for here. So you can see why we put an open circle above it. So an interval notation, we have to express this graph in interval notation. So to do it, we say anywhere from, and this is negative infinity over here, right? And this is positive infinity. We say that the variable is x. So we say x is anything from negative infinity up to the negative 6. And we use a parentheses. Remember, bracket is for equality. The parentheses is for non-equality. So it cannot be equal to 6. So make sure you put a bracket. A parentheses. Union with, we're going to pick right back up at the negative 6 and say infinity. So this is another way of saying x is anything except for negative 6. So there it is. We have right there. That's it. Good job. Yeah, they're going to up the ante. Anyway, find the domain of the function. If you see no square roots, if you don't see any denominators, this is all real numbers, okay? That's it. So no radicals, no square roots, no funny business going on. It's all real numbers. So there's nothing you can plug in here that will make this undefined. As a matter of fact, this is a parabola. It's a U shape. And parabolas are defined everywhere from negative infinity to positive infinity with respect to x. Remember, domain, they're asking you what could your x values be? What has to be excluded? Like this, we have a denominator, right? So right off the bat, the only thing that will make this undefined will be what will make the denominator equal to 0. So all you do is set the denominator equal to 0 and solve for x. This is a factoring problem, right? Make your two parentheses. Let's attempt to factor it up. We have x in front, x in front. Now we have a minus right here. So automatically we need a negative times a positive or a positive times a negative. It doesn't matter. Factors of 63, that would give you a 2 because we have a minus here, we're going to subtract the factors. Whenever your c is positive, you add the factors. Whenever your c is negative, you subtract the factors. Remember, we have ax squared plus bx plus c. Whenever your c is a positive, you add the factors. Whenever it's negative, you subtract the factors. So let's find the factors of 63. That'll be 63 times 1. Remember our trick, we can't divide it by 2, but we can divide by 3, we get 21. Multiply by 3, we get 3. Divide by 3, we get 7. Multiply by 3, we get 9. And those are all the factors of 63. Which one do we need? We need the one that will give us a 2 when we subtract them. So it has to be 7 and 9. So where would they go? Where would the 7 and 9 go? Would the 7 be here? Here's how you determine it. You look over here at your B term. The larger number has to be whatever your B term is, the BX portion. So the bigger number here is 9. That's the larger factor. So it has to be the same sign as the middle. So we're going to put the 9 here, which means the 7 goes here. So you can refer to my factoring video. It was one of the first videos I made. Yeah, I think I did. All right, anyway. All math is alike. Anyway, so x is equal to, or I should say, let's go ahead and put a slash across here because we're figuring out what x cannot be equal to. X cannot be equal to the opposite of this, which is -9. The opposite of this, which is 7. So -9 and 7. So what is your domain? I like to graph it out first. You know, put your key players down. -9 will go somewhere here, and 7 will go somewhere here to the right of it. So we can just put open circles above what it cannot be equal to. So we're going to shade everywhere, but not those points. So we're going to shade here to the right. We're going to shade in between. The in-between values are okay. And we're going to shade to the left. So it's everything except for those two values. So that's -infinity. All the way up to -9. That's where you put a parentheses. Union with, because we have an open circle, you have a break, a gap. Union with, now we need every value between -9 and 7. So parentheses, -9 and 7. Another union with, because we have another gap, and then 7 all the way to infinity. So that is our interval notation. So let's input it correctly and just take your time with it. We have a parentheses, -infinity. So click -infinity down here, comma, commas are important, -9. Union with, then we have -9 to 7. Union with 7 all the way to infinity. And don't forget to close it up with parentheses. Good job. All right, next. Okay, find the domain of the function. Okay, I will tell you this. We have two separate functions, right? They don't have to be together. You can solve them both separately. All right. So x cannot be what here? What would make the bottom equal to 0? -6 will make this equal to 0. -9 will make the other one equal to 0. So x can be anything except for -6 and -9. So which one of these interval notations reflect that? It has to be this one. So -9 is not included here because of the parentheses. We can choose values in between -9 and -6. It's just like the example we just did last. So when it's in this format here, just make sure you, if you have like two numbers that are excluded from the domain, just make sure it looks like this. You have parts to the left, the ones that are in the middle, and then to the right. So this is it. This is 6. C. This is an interesting one. So once again, it's domain. So we only focus on the denominator and nothing else. And this knowledge will take you all the way up to calculus, through calculus. So let's focus on just the denominator. So we have x squared plus 9. And then we also have x squared minus 1. So take a look at this one. We're going to do something different. All right, can I equal 0? Can I equal 0? Because we're trying to figure out what will make it equal to 0 so that we know that x cannot be equal to those particular numbers. So look at it this way. If you were to minus 9 from both sides, you get x squared is equal to -9, right? But then when you attempt to use your square root property from the previous chapter, you cannot take a square root of a negative. So this is going to have no solution. So x can be whatever it wants. There is nothing that x can be that x cannot be. X can be anything, no matter what you plug into x squared plus 9. Because you're squaring it, it's always going to be a positive anyway. When you add 9, it's never going to be 0. So you can plug whatever you want into the first function, the first fraction. What about this over here? x squared minus 1, if you remember, x squared minus 1 can be factored. You get x plus 1, x minus 1. Remember the difference of squares? So you get x equals 1 and x equals -1. And remember, we're going to put slashes, so x cannot be equal to those two numbers. You can do it that way, or you can attempt to do the square root property like we did before. You can say, okay, let's write it down. X squared minus 1 cannot equal 0. Add the 1 to both sides. You get x squared is equal to 1. And when you do the square root property, it's allowed because you're not taking the square root of a negative this time. So x is equal to, you just took a square root of a number involving x. So that's a positive and a negative. Remember the plus and minus, and then you have 1. And isn't that essentially saying the same thing here? +1, -1, +1, -1. Let's put out slashes. And yeah, so it's all tied together, whichever you choose. If it's factorable, do it this way. If you want to use the square root property, go ahead and bring it over to your right and take the square root. So you still get plus or minus 1. So x cannot be -1 and x cannot be +1. Let's illustrate that on our graph. So here's -1, here's +1. X can be anything except for those. So let's put open circles above. X can be anything in between, like 0. X can be to the right, x can be to the left, but not including. So -infinity to -1, union with -1 to infinity. I'm sorry, what am I saying? -1's a +1. I'm getting carried away here. And then 1 to infinity. All right, and that's it. So the first fraction ended up having an all real number type of solution for your domain, but the second one did not. So you want to check all of your fractions. So anytime you can get a denominator somewhere, you want to set that denominator equal to 0. And you're going to see possibly in the next few examples that we're going to have many denominators and you just set every one of them equal to 0. And solve for x. All right, excellent. What is the domain of this function? The domain, now we don't have a fraction, but we do have a radical. And you remember the rules of radicals. Radicals cannot be negative on the inside. So if it can't be negative, and bear with me, we're going to use some terminology here. So if it can't be negative, doesn't that mean, if the inside cannot be negative, doesn't that mean that the inside has to be greater than 0? Isn't that essentially saying the same thing? When you have a number line like this, and you have 0, if it's these are the negative values, -1, -2, going to your left, correct? And these are the positive values, 1, 2, 3. Anything that's to the right, anything that's greater than 0 will be positive, right? Right. Anything that's to the left will be negative. So, this is essentially saying the same thing. We want everything inside the square root to be greater than 0. Now, can we put the equal to portion? Well, can you take the square root of 0? Yes, the square root of 0 is 0. And I have a very funny story about that where somebody was trying to debate me in some video game store. I guess he called himself a nerd. I'm much more of a nerd than he is, especially in math. He told everybody that the square root of 0 doesn't exist, but no, that is not the truth. The square root of 0 is 0. And it's not like I can convince the guy. Once somebody has their mindset on something, there's no telling them. So listen, we're going to put the equal to portion here, okay? The only time where it can't be equal to is when it's inside of the denominator. It can't be equal to 0 when it's in the denominator. But with square roots, a square root can be greater than or equal to 0. Why not? Anyway, we just basically solve for this inequality. Subtract 10, subtract 10. So x is equal to, x is greater than or equal to -10. So let's go ahead and put that in graphical form. We have -10. X is greater than -10. So we're going to use a bracket and we're going to go to the right of -10. So in interval notation is like we just copy and paste this. We get -10 starting here all the way to infinity. And please make sure you put a parentheses next to the infinity. You can't put a bracket because you can't equal infinity. So -10 to infinity, there it is. All right. Let's see. Find the domain. Now look, we have a denominator and we have a radical. So it's like we're gonna take a combination of what we learn here, and we're gonna combine the two concepts together. So just bear with me. All right. So let's look underneath the radical. We know the radical has to be greater than 0. It must be because it's a radical. It has to be positive, right? Now, can we put the equal to portion here? Can it be equal to 0? Well, it's underneath the fraction. It's underneath the denominator. So in this case, we cannot have it equal to 0 because denominators can never be equal to 0. So in this particular case, when you have a blend of the two ideas, when you have a radical that's also underneath when you have a square root that's also a denominator, you cannot put the equal to, and everything should be okay. So let's go ahead and add 11 to both sides. You get x is greater than 11. That's it. So let's graph it up. We have 11. If it's greater than 11, we're going to go ahead and put a bracket here and just shade everything to the right of 11. So copy and paste. Remember, this is infinity. So this is 11 all the way to infinity. And that's it. So yeah, this is as tough as it gets, I believe, when they blend the two like that. Just take your time. Just know that you cannot put the equal to next to the 0, the greater than symbol, so we should be fine. And oh, we're not using the bracket. My apologies. We're not using the bracket because it's not equal to 11. Remember, that was just a little mistake. I'll try not to do that again. We're using a parentheses because of this guy right here. So this is a parentheses 11. And look, they have the bracket 11 right there to throw us off. But it's a good thing we didn't submit it yet. Nice work. I make mistakes too. What is the domain of G? Now, we don't have a fraction, so we are allowed to set this thing equal to 0. So take the inside of the radical, 2x plus 14 greater than 0, always. Now, do we put the equal to? Yeah, sure. We don't have a fraction. It's allowed. Let's go ahead and solve. So minus 14, minus 14. We get 2x is greater than or equal to negative 14. Divide by 2, divide by 2. You get x is greater than or equal to negative 7. Let's graph it up. We have negative 7 here. X is greater than or equal to negative 7. So we're going to use a bracket because of the equal to, and we're going to shade everything to the right of negative 7. So interval notation, this is negative 7 to infinity, and that's all she wrote. So yeah, you can see, I know I'm going fast, but you can rewind. Everything I'm saying is legit. If you follow these steps, you're going to get a good grade. And I'm trying to put a parentheses in there, but it's not letting me. All right, got it. All right, well done. All right, next, what is the domain again? Once again, we're going to set it greater than or equal to 0. Solve for x. Just like clockwork. Okay, so let's do this one quickly. 12. I'll do it fast for you guys. 12 minus 2x greater than or equal to 0. So I'm going to subtract the 12. We get negative 2x is greater than or equal to negative 12. And here's the tricky part. We're going to have to divide by negative 2, correct? Remember in the last section where you divide by negative 2, you're going to flip the alligator to the other side. Yeah, this is kind of like an alligator with the teeth. Alligator, I guess, has 2 eyes, looking angry. I don't know. It's an alligator. That's what they taught us back in the day. Anyway, we flip the alligator around. Negative 12 divided by negative 2 is positive 6. Now reading this is x is less than or equal to positive 6. So we have 6. We're going to go ahead and shade is equals, and we're going to shade in the opposite direction all the way to infinity with the negative infinity. So copy and paste this thing in just the way it looks, the same orientation. We get negative infinity all the way to 6 with a bracket. So that's it. This is the interval notation. So negative infinity all the way to 6 with a bracket. Fantastic. All right, this is going to be shorter than the last one. Yeah, definitely we're going to get through this one. All right, two radicals, two different inequalities. This is going to be a compound inequality, like you remember. So we're going to set this one greater than or equal to 0. We're going to set this one greater than or equal to 0. And remember, we're allowed to do equal 0 because there's no denominator. It's allowed to be equal to 0. Ready? Add 4, add 4. X is greater than or equal to positive 4. Minus 8, minus 8. X is greater than or equal to minus 8. Now we're going to put both of them on a number line. These are our key players, negative 8, positive 4. And very carefully, just step by step, just go through each of them separately. X is greater than or equal to 4. So greater than or equal to 4 is a bracket going in the positive infinity direction. Remember, this is positive infinity. This is negative infinity. What about the other one? X is also greater than or equal to negative 8. So, we'll use the same color. So greater than or equal to negative 8 will be from 8 with a bracket facing in that direction as well. So remember, this is a compound inequality. Where do they have an overlap? Where do they have something that agrees? They both agree right up in here. I'm just going to make that in pink. You see I have one shade above the other, one line above the other. So they're also going to share the same symbol. Whatever symbol's there, that's what they're going to have. And that's it. This is a bracket starting from 4, right? Isn't that what this is? It looks a little messy, but that's what it is. And it's going to go all the way to infinity. They both agree at that particular section. So, yep, 4 to infinity, there it is. So nice, so nice. So go over this video. You should be okay. Hey, we have a radical on top, a denominator on the bottom. So separately, let's evaluate that. So let's do the radical first. We're going to just set whatever is inside the radical greater than or equal to 0 because it's not underneath, right? It's not in the denominator, it's in the numerator. So you're allowed to put the equal to 0 portion. And we always put the greater than symbol because we always want the inside of the radical to be positive. What about the denominator? Well, the denominator cannot be 0. So we're just going to take the denominator, x minus 9, and say that cannot be equal to 0, whatever it is. Now, all we're going to do is solve for x for both of them. So add 4. We get x is greater than or equal to 4. Over here, add 9. We get x cannot be equal to positive 9. So how are we going to put this on a number line? I'll show you. Okay, put your key players down. We have a 4 somewhere here. We have a 9 somewhere over here. And remember, we only use the graph as an aid, and you never know when they might ask you to graph it again. All right, anyway, let's address that cannot equal to portion, and we're going to do it in red. Let's put an open circle here to show us that the positive 9 is off limits because x cannot be equal to the 9. So we're not going to shade the 9. We're just going to put an open circle around there. So just in case we get some shades, we're just going to approach it but not go through it, okay? So don't touch the 9. Anyway, x is greater than or equal to 4. So if it's greater than or equal to, we're going to have a bracket there, and it's going to go in this direction. We're not going to go through the 9. We're just going to jump over it and pick up after it. So that's it. That's the graphical representation. Remember, this is negative infinity. This is positive infinity. So how do we put our graphical notation into interval notation? Well, go from left to right. Here's where the redness starts. You go from 4. You're going to keep on going until you hit the 9. This is not equal to, so you're going to need a parentheses. We're going to pick right back up after we leave the 9. So make a union because we have a gap, we have a space. You're going to pick up at the 9 again, and then you're going to shoot all the way to infinity. And that's it. So this is when you have a square root and a denominator in the same problem, and they ask you for a domain. So x can be anything between It could be equal to 4 all the way up to 9, not including, not inclusive. Or it can also be greater than 9. Anything greater than 9, from 9 to infinity. Yeah, let's put a bracket here. So 4 to 9. And then union with 9 all the way to infinity. Well done. Okay, now we're done with the domain stuff, it seems like, for now. Now we're going into the composite function stuff. And it's not as bad as it looks, I promise. All you do is follow the steps they give you, and we're going to simplify as much as we can. And, oh, they do want us to find domain. All right, so here's a rule, okay? Find domain first. I want to say find domain before, and I emphasize on before, simplifying. Okay, so find your domain before you start finding an LCD and doing all that crazy stuff and multiplying, because you're going to see there's going to be some crazy stuff going on. But find your domain beforehand, okay? So let's just jump right in. This first part is telling you to take your f function and add it with your g function. Now, this x means that they're both of x. This is f of x plus g of x. So don't get too worried about the notation there. They're basically telling us to add the two functions together. So I'm going to write it just like they have it. So f plus g, they're both of x, is equal to your f function, which is f of x equals 5x plus 1. So this is going to be the f, right? That's the that's the f portion, the f of x, plus your g. What is your g of x equal to? X plus 6. This is the f plus the g. So now that we have that, now that you know that those are the elements, let's just erase this. You can rewind if you need to grasp that a little bit more. We're basically going to add those two together. So 5x, the only like term we have is with the x, so that's 6x, and then plus 7. That's it. Now, I know I told you to find the domain before simplifying, but they're asking us to solve it first and then we find the domain, so it's kind of like making us backtrack this a little bit, but don't worry. We didn't have any fractions, we didn't have any square roots, so the domain is going to be negative infinity to positive infinity, so fear not. Now we're going to take the f minus the g. So this is f, this is f minus g. They're both of x. Just take your f, 5x plus 1, and minus the entirety of whatever your g is. And notice I'm using a bracket instead of a parentheses. I just like to use a big roll bracket. You can use whatever you like. So this is your f of x minus your g of x, x plus 6. Just put it right in there. Close it up. So we're going to distribute this whole g of x here with the negative 1. So this is still 5x plus 1 minus x minus 6. We distribute this negative 1. Remember, there's a negative 1 here. You distribute it, and we get this. Combine like terms, 5x minus 1x is 4x. 1 minus 6 is negative 5. So we get 4x minus 5. And these are composite functions. Whenever you start combining functions, multiplying functions, they call them composite. Okay, what is the domain? Now, before we started simplifying, right up in here at the first line, always look at the first line. Do we have any fractions or square roots? No. So this is negative infinity, positive infinity. Well done. Now, f times g, here's where it gets interesting. So let me go ahead and erase all the stuff here. So f times g. All right, so we're just going to take the f. So, I'm not even going to write the left-hand side. Let's just go ahead and do the math. We're just going to take your f. Let me whatever, f times g, okay, of x, whatever. We're going to take the f, and we multiply with the g. Now, do we have any fractions or square roots? No. So we're just going to say the domain is negative infinity to positive infinity. So we have to take our time and distribute. And they didn't tell us to simplify. So, I wonder if we can get away with not multiplying them all now. Let's see if we can just, as long as we put the idea, let's see if they'll let us slide with it. So x plus 6. And they didn't say to simplify, did they? So look, they just want you to put the functions next to each other and in parentheses. Parentheses are very important, okay? Okay, domain. There are no fractions, no square roots. So this is negative infinity, positive infinity again. F divided by g. So we're going to have a denominator. So we're going to have a domain, a different domain now. So we're just gonna, this is f divided by g. You can put the of x portion if you want to. You can put this in parentheses or not. We can just not put any of that stuff. We know what we're looking for. Okay, so let's take our f, 5x plus 1. We're gonna divide by our g, x plus 6. And there's nothing left to do here. You can't simplify anything. There are no GCFs, so you can't divide. We're done here. So 5x plus 1, and this is over x plus 6. Excellent. Now, what is our domain? Now we have a denominator. Okay. So remember, whenever you're looking for a domain, you just take the denominator only. And this is for domain here. You take the denominator only instead of equal to 0 with a slash across the equal sign to say that x cannot be equal to whatever we find. Subtract 6, x cannot be negative 6. That's correct. Wouldn't negative 6 make the bottom equal to 0? So x cannot be negative 6. So we would choose that one. So remember, you make a number line, you put your negative 6, put a circle, an open circle there, shade everything else. This is positive infinity, negative infinity. So negative infinity all the way to negative 6. Close it up with a parentheses because it's not equal to. We have a big space here. Union with negative 6 to infinity. There we go. Well done. All right, next. Now they're going to up the ante just a little bit. We're adding the functions, right? So let's just save some time. Look at this function here, 4x squared minus 6x plus 2 and x minus 1. We're just going to add them together, okay? And just combine like terms. So we have 4x squared there. We don't have another x squared term over here, so we're just going to put 4x and then square just like that. Negative 6 plus x will give you negative 5x. 2 minus 1 is just going to give you a positive 1. That's it. Good job. Okay, what is the domain of f plus g? The domain, there are no fractions, no square roots. Negative infinity to infinity. Nice work. F minus g. So f minus g. All right, so it's the same thing. We're going to distribute that negative over here. We're going to go ahead and write that one down. I'm going to delete everything. Yeah, because we're distributing a negative, but you're going to see it's the same thing. So you know we're going to keep, so f minus g. All right, so you know we're going to keep the f right here. 4x squared minus 6x plus 2, right? Now for the g, remember, put a minus, and you're going to subtract everything in there. So the g of x function is x minus 1. Let's rewrite it. And let's distribute that negative 1. So that'd be negative x plus 2. Combine your like terms, we get 4x squared minus 7x, and then plus 4. And that's it. So 4x squared minus 7x and then plus 4. Oh, what did I do? What did I do? What did I do? What did I do? All right, 4x squared minus 6x plus 2. Negative x. Oh, why did I put a 2 there? Darn it. Why didn't you guys say something? Anyway, plus 1. So this is actually a 3. So let's make that into a 3. It happens. 3. Okay, domain, no fractions, no square roots. Negative infinity, positive infinity. F times g. So we're just going to take all of f and multiply with all of g and just leave them in parentheses. There is no need to simplify, and technically it's already simplified if it's in factor form. So 4x squared minus 6x, then plus 2, close it up. Finger slip. Okay, x minus 1. Okay, no fractions, no square roots. You know what that means. All right, f divided by g. Let's make a fraction bar. You can hit it by hitting the backslash. So you're going to take your f, 4x squared minus 6x, and then plus 2. We're going to divide this by x minus 1. Hit enter. Now what did I do? Oh, hey. I got carried away, but check this out. The top can be factored. That's the only way that this can be wrong. The top can be factored. I'm not gonna lie. I got a little carried away. Not gonna lie. It happens. We're gonna factor the top. We're gonna take out the GCF, and then we're gonna factor it as much as we can and see if the top and bottom will cancel. So we have 4x squared minus 6x plus 2 over x minus 1, right? So, yeah, we have to, it does say simplify your answer. Yeah, they were giving us hints. I got carried away. We can take a 2 out from the top, can't we? We get 2x squared minus 3x plus 1. And this is over x minus 1. Now, can we factor the 2x squared minus 3x plus 1? Let's see. Let's take it out and bring it here to the side for a second. We'll bring it back, I promise. Remember our factoring method, the AC method? We take off the 2, we have x squared. We'll leave the middle alone, and we take the 2 and multiply with that 1, so we get plus 2. We can factor this normally. We get x. This is a plus right here. The signs are going to be the same because this is a plus. The signs are going to be whatever that is. Factors of 2, 1 and 2. They do add to give you 3, so yeah, we're good. And now don't forget, the 2 that was up here, we're going to bring it back and divide those factors. This is a good factoring method. If you don't like to do math computations, it really works well. When you have a fraction left over, just put whatever that bottom number is and put it in front of the x. Refer to my last videos about this method. So this is the factor version. We're done. So over here we have a 2, and then we have x minus 1. Remember, we're getting it from here. X minus 1. Two x minus 1 all over x minus 1, and take a look. Yeah, they did cancel. And notice that we didn't have a parentheses on the bottom at first, but I'm going to put it there because we're canceling. So you can have a parentheses anywhere, just as long as you put it over the whole numerator or the whole denominator. And I want to do it just so we can see that they go away. So we have 2, open parentheses, 2x minus 1. If you want, you can distribute, but it's not necessary. But we were actually able to simplify. So we have to put that in. So this would be, I'm going to distribute 4x minus 2 just to prove a point. Excellent. Now it's going to ask us for our domain. Remember what I said a couple minutes ago? If you were to try to take the domain of the simplified result, it's going to give you the impression that, okay, there's no fractions, no square roots, so there is no domain. Wrong. Remember, I said to take your domain of the original before you start simplifying. Do we have a denominator? Yes. X cannot be positive 1. 1 will make the bottom equal to 0, right? 1 minus 1 is 0. So X cannot be a positive 1, and it's that one right there. So don't let them trick you. Take your domain before you start simplifying, okay? All right, the same deal. Let's go ahead and do what they say. We're going to add the functions together, f plus g. So that's the square root of x. And we're going to add, so make sure you hit the arrow to get out of the square root, to get from the inside. And we're going to put x minus 8. There are no like terms here. The domain, there is only one square root, so we have to focus on that. X has to be greater than 0. So it's that right there. That's it. Okay, f minus g. It's almost the same thing. We're just going to take our f, which is the square root of x, and we're going to subtract the whole g function. So if you're going to subtract the x and subtract the negative 8, make sure you distribute the negative. That'll be negative x and then plus 8. Right? We distribute the negative. All right, fantastic. Okay, what else do we have? What is the domain? Once again, x has to be greater than or equal to 0. We focus only on the square root portion. And just to give you a little refresher so that, you know, I write something down for you guys. You just take whatever's inside the radical and set it greater than or equal to 0. And that's it. X has to be greater than or equal to 0. Oh, and don't forget the graph. You're at 0. Greater than or equal to 0 will be in that direction. Okay, so yeah, that's it. Now we're going to start multiplying. So to multiply these two functions, you're going to have the square root of x. Remember, we're multiplying here. The square root of x times, and we're just going to put we can put a times here. We're not going to use it, but I'm going to show you. We're going to put times, and then we're going to put the x minus 8 in parentheses like that. Now, if you do it this way, and if you don't write the dot, it's perfectly fine. Just put them side by side. So we have the square root of x. It's going to be side by side with x minus 8. That's it. Nice work. Okay, what is the domain of this? Only focus on the square root. X has to be greater than or equal to 0. All right, we're going to divide everything. Here's where it gets a little bit difficult. Hit the fraction button. We're going to put your f, which is the square root of x. And we're going to divide by x minus 8. Domain. X has to be greater than 0, and x cannot be 8. So let's illustrate that. It's a little too much to keep in our brains. So with the square root, x has to be greater than or equal to 0. So that's already solved. And x cannot be positive 8, right? So on the number line, we have a 0. We have our 8. Those are our key players. So x cannot be positive 8. So we're going to put an open circle here, just in case. X is greater than or equal to 0, so we're going to put a bracket here, shade everything, but do not shade the 8. Pick right back up, go to positive infinity. And we're done. So this is from 0. It's going to go all the way up to the 8. There's a space in between, so union. Pick up right back from the 8, and you're going to go all the way to positive infinity, so 8 to infinity. And there it is, just like that. All right, next. Okay, good. We got through the crazy domain and composite stuff for now. I'm going to show you guys how to do this one. This is red. You may read it as fog or even gof, G-O-F. The idea is that we're going to plug one function into the other one. Now, so far, we've been adding functions, subtracting them, multiplying, and dividing them. Now we're going to plug one function into the other one. And let me show you how it's done. So, for example, F, O, and then G. It's like a small O. I don't even think it's the letter O. It's like a small, I guess, open dot or something. Here's how I want you to do this. All right. I want you to start from the right. And I want you to take whatever's in here, because sometimes this X will be a number. It can be a 3 or something, or in this case, a 4. So write down fog or gof. You see they're going to give us gof in a second. You read this as f of g of x. So start from the X, and you're going to plug whatever's in there into your G. And whatever the heck you get, you're going to plug that into your F. That's it. You start from the right. And I know we read from left to right, but we're going to pretend that we're in Japan now. Okay. We read from right to left. So plug whatever's in here and go to your left. Okay. So now what? Well, now we find fog. So looking at f of g here. So we have f of g of x. So f of g of x. What do we do? Well, what is our f function? The f of x is equal to 5x. G of x is equal to x plus 8, correct? Let's go from right to left. You're going to plug the x into the g, so that's your g of x. That's this portion down here. So we're going to take this whole portion, the x plus 8, and we're going to plug that into the f. So all of this right here is going to go right in there for your x. So if you like, you can make that into a parentheses and say that instead of x is going to be x plus 8 now. So ready? We have our 5. And we're just going to open up parentheses and put the whole x plus 8 right in there. I said we took this whole x plus 8 right here and put it right into the x. So there's our 5, right? And now this little x becomes x plus 8 now. You plug it right in. We're done. And it does say to simplify, but I think we can get away with, yeah, if it's in factor form like this, this is technically simplified, but we're going to see what they want. Yeah, excellent. Now, this is telling you to go in reverse. So they want you to find gof now. Very similar to fog. So you have g of f of x. You're going to take whatever this is. You're going to plug it into your f. And then whatever that is, you plug it into your g. So let's do it. Remember, f of x is equal to 5x. And g of x is equal to x plus 8, right? So we're taking the x and plugging it into the f. We get f of x. And now we're going to take whatever the f of x is, and we're going to plug it into wherever we see an x. So right in there, let's put parentheses there. So g of f of x is equal to, you plug the 5x in there. So let's write it. So it equals, this is a 5x now. And then we have our plus 8. That's it. 5x plus 8. It takes practice. So, do a few of these until you're comfortable. And if you do enough, you're going to get them right. Now read this. F of g of 4. There's 2 ways you can do this. If you already went through the trouble of finding the first part, the f of g, which we did, we have 5 times x plus 8, right? If you went through all of that trouble, just plug the 4 into your fog function, your f of g of x function. So if you plug a 4 here, you get 4 plus 8, which is 12, and then 12 plus 5, which is 60. That's one way you can do it. If you wanted to do it the other way with the arrows, like if you're comfortable with the arrows where we start from right and go left. So here's what we're looking for. F of G of 4 now. So it's not an X. We take the 4, we're going to plug it into your G function, and then you're going to plug whatever that is into your F function. And watch this. So let's plug the 4 into your G function. What is G of 4? What is our G function? The G function is X plus 8. You plug the 4 in there, you get 4 plus 8, which we know is 12. That's this portion, the G of 4. Now that we have a 12, we're going to plug the 12 into the F. So what is our F? This is F of 12 now because we're plugging the 12 in there. And this is 5 times the 12 that we're plugging in. And you still get 60. So no matter which way you want to do it, you're still going to get the 60. Okay. And it's completely up to you. If you already did the work of finding fog and goth, just plug whatever they're asking for into that function. So for example, we have goth of 4, right? Up here we have goth of X. So just replace all of your X's with the 4. So that would be 5 times 4, which is 20. 20 plus 8 is 28. Can't go wrong. And that's it. And that's what we're going to do for this whole section. Okay. So over here, let's find fog. So F of G of X, we're going to plug the G. So plug this in here. Plugging the X doesn't do anything. Then we're going to plug the G into the F. So if we're plugging G into the F, I want to do something differently. I want to draw my F function because I know I'm plugging G into the F. I'm going to just make my F function, right? So that's 5x minus 1. But then I want to erase the X and make a huge parentheses so I can just put a whole function in there. You see that? So I give it a little room. I'm going to squeeze it in there. And what we're going to plug in is our G. So what is our G? 5x squared minus 1. So I'm going to sneak the 5x squared minus 1 right in there. This is the way that I do these. All right, we want to simplify. So distribute the 5. You get 25x squared minus 5 minus 1. Combine like terms, you get 25x squared minus 6. And that's it. So this is 25x squared. And then minus 6. Well done. G of F. We're going to plug the F into the G. So it's the same routine. So we're doing G of F now. Let's go from this direction. We're going to plug the X into the F. So that's F of X. So we're plugging the F into the G. So let's write the G function. So this is 5x squared minus 1, right? And wherever you have an X, I want to erase that X and make a big enough parenthesis so I can put the whole function right in there. So we're putting the F in there. What was your F equal to it? Your F function was 5x minus 1. And now we just have to simplify this sucker. So it's a little bit tedious, but bear with me. This is 5 parentheses. Isn't that 5x minus 1 squared? So it's 5x minus 1 twice. Right? Let's take our time and distribute. I want to do the factoring shortcut. You square the first term. Square the last term. Multiply the two together and then double it. So 5x minus 5x times negative 1 is negative 5x times 2 is negative 10x. Shout outs to Mr. Simmons from Diller High School. Minus 1. Distribute the 5. You get 25 times 5. 5 quarters. You have 25 cents. You have 5 of them. That's $1.25. X squared minus 50x plus 5 minus 1. So we have 125 x squared minus 50x plus 4. And that's it. So I'm not going to lie. That one was a doozy, but we got it done. All right. Let's input the whole thing in there. All right. So 125 something. Never mind. Okay, I was doubting myself for a second. Okay, f of g of negative 2. So rather than using the fog function for this, which we can, we will use it this time. We'll put -2, we're going to square it. -2 squared is 4. 4 times 25 is 100. 100 minus 6 is going to give us 94. We'll do it this time. Okay. But for the Goff, I don't like that function. It's just a little, it's too much to me. So we're going to try something different. We're going to do what we did before. Let's go ahead and leave that. We're trying to find Goff here. Let's call this the arrow method. I don't know. I like the arrow method. We're going to take -2, plug into your F, whatever the heck that is, plug it into your G. We can switch it up. We can switch our game up. When you're a mathematician, you want to know your options. You want to exercise those options and abuse those options. Okay, so let's take -2. We're going to plug it into the F. So f of -2 is equal to 5 parentheses -2 minus 1. You get -10 minus 1, so you get -11. We just got -11. We're going to plug that into your G. So that'll be 5 times -11. Remember, this is G of 11 here. I'm sorry, G of -11. Sorry about that. -11 squared and then minus 1. So this is -11 squared, which is positive 121. So this is 5 times 121 minus 1. That'll give us 605 minus 1. So this is 604. Well done. And that's it. All right, same deal. We're going to plug the G into the F. So when you plug G into the F, aren't you putting that x minus 1 right inside that square root? So that'd be the square root of x minus 1. Got it. Let's plug the G. I'm sorry, we're going from right to left. Let's plug the F into the G. If you take the square root of x and plug it into where the x is, you just get the square root of x minus 1. Fantastic. Let's plug 2 into our fog function. 2 minus 1 is 1, square root of 1 is 1, so this answer is just 1. We're going to plug the 2 into our Goff function. The Goff we found was the square root of x minus 1, so that's going to be the square root of 2. And there is no square root of 2, so we're going to leave it there. There's no perfect square root of 2. And then we're going to just put the minus 1 right next to it. See, we just plug the numbers in. We're going to put the G into the F. So here's your G, that's x minus 9. We're going to plug it right in there. So that's going to be the square root of x minus 9. What is the domain of the fog? Well, x minus 9, we're going to set greater than or equal to 0. So we're going to add 9 on both sides. So x has to be greater than or equal to 9. So remember in the previous examples, that's just 9 to infinity. F of G, we're going to plug the G, go from right to left. We'll plug the G into the F. So here's your G, 5 minus x. We're going to plug it into the F. That's going to be the square root of 5 minus x squared. Doesn't it just come out of the radical? So we're going to write this one down. We can't do everything in our heads. So I'm saying this is the square root of 5 minus x. The whole thing is being squared and then plus 8. Those two will cancel out. You're just left with 5 minus x plus 8. You get 13 minus x, or negative x plus 13. So 13 minus x. Fantastic. What is the domain of f of g? The domain... Now remember, we always find the domain before we start simplifying, right? That's right up in here. So let's put domain right there. Now, we have a square root, right? So take the inside of that square root before you square it. Take the inside of it and just say square root equal, say that it's greater than or equal to 0 and solve for x. So minus 5, you get negative x is greater than or equal to negative 5. So x, when you divide both sides by negative 1, so let's divide both sides by negative 1 to get rid of the negative. Remember, you flip the alligator to the other side, and then you simplify. X is less than or equal to 5. So here's your number line. Sorry about that. Here's your number line. Here's 5. Less than or equal to 5 would be in that direction, to negative infinity. So this is negative infinity to 5 with a bracket. And that's going to be the end of this section. At the time of download, what's weird is that it looks like I'm going to upload this video first before the second one, because the second one is still exporting for whatever reason. We got our 100%. Sorry about that. You're going to get this in reverse order. So more than likely, you're going to get this video, and then you're going to get the first chapter, the chapter that comes before or after, because it was a pretty long video, but you have everything you need. Good luck on your exam, and thank you so much for watching.